drawn. We've got our bottom plate, our stud, and our top plate. Now, we also need to have some other timber members. Now, that might be a noggin that's halfway in between. So when we're looking at the stud doesn't need to have a solid line. So we might represent that just as a thin line at the moment because that's in the background. We'll be repeating this, and that might be 1200 millimeters up. Now I'm trying to draw this incrementally or one bit at a time just so it makes sense to you. Now, of course, the stud is actually continuous, but this noggin goes between them. So I could leave it like that, or in terms of a diagram, I could split it. I don't need to show that running all the way through. We're then going to show how the roof and the ceiling connects to this. In this case, I'm going to represent a truss-based roof. So that's going to be the same system as what we have here. So that's going to be, in this case, running up on a 22.5 degree. So I'll type that in. So I'll go A 22.5. And we'll make the depth of that rafter 90 mil. Now that'll be extending past to create an eave, and it'll be extending up all the way eventually to the ridge. At the moment, we'll just leave it sitting like that. We're also going to have a ceiling joist. So that ceiling joist will be doing a similar thing, starting from that outside point. In this case, it will be going up. Again, we'll do that as 90 mil. Now, in a traditional situation, we'd have a rafter and we'd have a ceiling joist. The rafter might be deeper and the rafter might be notched. In this case, we're not notching it because this isn't a traditional ceiling frame. This is a truss, which means they can't run past each other like they are at the moment. So in a truss, this one is chopped, and then these two are fixed together, and so we'd normally have a nail plate, or gang nail, which would sit over it, something like that. I'm not going to represent that at the moment. We're just going to draw the timber elements. Now this ceiling joist again continues through, and we're going to hide the relationship of that eventually, but this is basically what it's going to look like. Now we could say that we could describe the overhang of the frame based on the outside of the timber frame, and that's how a carpenter would normally understand it, a builder. And so we could say that the overhang from here is 600 millimeters, or we could say that the overhang is from the outside of the wall to the outside of the timber frame, and that's how, if we were trying to describe the shading for basics, we'd need to explain it. So if we were talking about a brick veneer building, so I'll quickly represent what that would look like. So we're going to get our brick. So let's change this to brick cut. We'll have a black line and we'll have a light orange background. And the size of the brick, I'll use the different method here. I'll use a rotated rectangle, is 110 by 76. And that brick is going to sit 50 millimeters away from, that didn't work, let's try again. 50 millimeters away from the frame. So we could say that the 600 mil overhang is either from the outside of the frame or from the outside of the brick. In order to be consistent, I'm just going to, at the moment, say that it's from the outside of the brick. The timber then would be cut vertically. So no matter what angle the rafter was at, it will normally have a vertical cut, and then we can have a fascia and a gutter sitting outside of that. Now on top of the rafter, we then need to have timber battens. That batten is going to create structure or support for the tiles or the roof sheeting. At the moment, we're going to represent that as a 45 by 45. And just like before, we'll use lines to create that cross through it. And the idea here is we want this to be aligned with that edge. So we'll grab all of these elements and drag it across until it meets that point. We'll group that together because we're going to repeat it. I'll take that batten, move, multiply, and I want to have this at a spread of, we'll just say 300 millimeters at the moment. And so this is based on the idea of a typical tile. We're probably going to need to have these battens quite regularly. 300 is fairly typical for a tile, but of course it depends on the actual tile, and that will define the actual spacing requirement. So at the moment, we've got our very quickly represented, we've got our wall frame, we've got our roof frame or our rafter, we've got our ceiling frame or ceiling joist, and then we would have some type of, in this case, a trussed roof, so we'd have some type of a web. Now I'm just going to represent this indicatively. So we'll have, let's say it's 45 degrees. And we'll chop this off there. And we'll chop this off there. And then of course this web would be then extending up and meeting up with this one somewhere further along here, which is going to be outside of our detail. So where do I stop drawing the detail? Of course, the point is, like I showed you at the start of this, it needs to fit onto the drawing. And I don't need to show all of this. So what I'm going to focus on is the areas of critical importance. So I'm going to focus on the junctions. So I'm going to focus on an area where we see the eave and we see the way that the wall meets the roof. And I'm going to focus on critical areas where the wall meets the floor below or meets the ground below. So these are the areas where I'm going to focus. And of course, if I had a window, I might focus on how the wall relates to the window as well. So they're the areas that I'm focusing on. We're not going to need to keep modeling or detailing 2D drawing beyond all the way for the whole building. That would be a waste of our time.